Good day and welcome to our topic 3 on our module 1 for our basic level training on antimicrobial agent. And I hope you viewed our topic 1 and topic 2, and now we are going to start our topic 3. And let me share my screen with you, so that we can continue with our topic 3. So in our topic 3, we are going to discuss inhibitors of cell membrane function. And I am Dr. Teke Apalata, an associate professor of clinical microbiology and infectious diseases. Okay, so inhibitors of cell membrane function. First of all, what we need to understand is that the cell membrane controls the passage of substances into and out of the cell, okay? And inhibitors of the cell membrane function interfere with the cell membrane structure, causing cell content to leak out, and eventually that will lead to the bacterial cell death. So this is what actually what happened, okay? And then inhibitors of cell membrane function, we have antibacterial agent like your polymyxin, and here we have mainly polymyxin B and colistin, and we have also cyclic lipopeptide, and that's an example is your daptomycin. And we also have antifungal agent that are mainly inhibitors of cell membrane function, and we also have some antimycobacterial agent that also act by inhibiting the cell membrane function. So we will briefly go through those antimicrobial agents. So let's start with antibacterial, like your polymyxin. And polymyxin here, we say that it includes polymyxin B and colistin. Now, what happened is that what you see here is the structure of a gram-negative. And once again, polymyxin B has a narrow spectrum of activity because it only acts against the gram-negative bacteria. And what then happened is that you see this is the structure of the gram-negative. I will tell you why it only acts on the gram-negative, not the gram-positive. Here you have a cytoplasmic membrane of a gram-negative, and you have a thin peptidoglycan layer, and we say that our gram-negative was covered by an outer membrane, and this is the outer membrane. Now, this outer membrane has a lipopolysaccharide that is negatively charged. So this lipopolysaccharide that is negatively charged, and now your polymyxins are positively charged molecules. So they are then attracted by the negatively charged LPS on the outer membrane of gram-negative bacteria. Now you understand that in a gram-positive bacteria, we don't have an outer membrane. So there is only a very thick peptidoglycan layer, and after that you will find the cytoplasmic membrane on the inside of the cell. But outside, there is no outer membrane. That's why polymyxin cannot act against the gram-positive microorganism. So those are positively charged molecules, and they are attracted by the negatively charged lipopolysaccharide that you find in gram-negative bacteria, Now, it binds to the cell membrane, it then alters its structure, and make it more permeable. So there will be a leakage of cellular molecules, and there will be inhibition of respiration and increased water uptake in the cell that will lead to the cell death. So we spoke about natural resistance to gram-positive because gram-positive don't have LPS. Another one is daptomycin. Okay, another antibacterial is daptomycin, and that is also an inhibitor of the cell membrane function. And daptomycin is used mainly to target gram-positive bacteria because they have a large peptidoglycan cell wall covering the plasma membrane. So if you want to use a membrane cell function inhibitors of a membrane, inhibitors of the cell membrane function, if it's a gram-negative, you can choose polymyxin, but if you want to use inhibitors of cell membrane function for gram-positive, then you have to choose daptomycin. So daptomycin will bind with the calcium ion, so you can see here, you can see the calcium, you can see the calcium ion, it's bind to with the calcium ion. Then from here, it will form a complex. And that complex that is formed will be then, that will make pore-like structure on the cell wall of the bacteria and allowing it to leak out the cell content. It will then allow it to leak out the cell content. Okay. So that daptomycin. Then we have antifungal agent. Like your polyen, the polyen, like your amphotericin B and nystatin, because those one bind to the sterol in the cell membrane lining. So here you can see they will bind to the sterol. We have ergosterol here. They will bind to the sterol. Then from there, they will allow potassium and magnesium to leak out, altering fungal cell metabolism, and that will result to the fungal cell death. Okay. And we have also other antifungal agents like your imidazole, like your ketoconazole, miconazole, clotrimazole, or fluconazole. Then those will inhibit an enzyme that will result in cell membrane leaking. Another antifungal is griseofulvin that acts by disrupting cell division, so it inhibits fungal mitosis, and that will lead to the cell leak. And beside anti-fungal, we have also antimicrobacterial agents like INAH, isoniazid, that inhibit the synthesis of the mycolic acid, and there it will also lead to cell death, through the leaking of the cell content. So those are actually what we discussed as inhibitors of the cell membrane function. Okay, so let's look at the first test. The first test here, it selects all that describe the cell membrane. Select all that describe the cell membrane. Anything here that describes the cell membrane, bacterial cell membrane. And are they selectively permeable? Yes, they are selectively permeable, as we saw. Fluid mosaic, yes. Embedded protein, yes, we saw. Phospholipid bilayer, yes. So all the above. So the correct answer is all the above. Now the second test is which of the following statement is not true about amphotericin B? Which of the following statement is not true about amphotericin B? So try to pause your video for 30 seconds and think about this. Which of the statement is not true about amphotericin B? A, they bind to sterol in cell membrane lining. This is true. because we saw that they bind with the sterol. It is a polyen together with nystatin. This is true. It is classified as a polyen. It inhibits ergosterol biosynthesis, yes, because it binds to sterol, and that is ergosterol, and inhibits the biosynthesis of ergosterol. Does it disrupt cell division by inhibiting fungal mitosis? No. And which one disrupts cell division by inhibiting fungal mitosis? Can you think about that one? That one? Which one? So you need to give me that answer. Which of the antifungal disrupt cell division by inhibiting fungal mitosis? Because this is not true about amphotericin B. So tell me which one it disrupts. Okay, so you need to give me an answer before we start topic 4 of our training. Okay, thank you.